Good morning. Can you hear me? Okay. Well, thank you so much for making time to come to the last day of the show to see Megmeet. I'm sure you want to know more. Who is Megmeet? Why we're growing so fast? And what we are going to release in the next year. So Megmeet, we are a public company established in Shenzhen. We are established in 2003. It's been 22 years. Our core technologies, power and energy. Our mission is we are engineered to empower the future of AI data centers. We are ranked in the top 3 global power supply companies. This is a report from last year, MTC report. $1.1 billion revenue, about 10,000 employees, and out of which 35% is R&D, so dedicated engineering staff, 35%. Globally, we are spread in 9 manufacturing centers, Thailand, China, Taiwan, and Dallas. Our R&D centers are in China, and we have about 24 FAEs that are spread across. So I'm going to walk you through some of the AI data center solutions that today you see the architecture. This is the main or most common AI data center architecture that you see today. Basically, these are all backed up with UPS or BBU. A 3-phase AC when it comes to the IT rack. The 1-phase and neutral comes into each power shelf, and the output is 50 volts DC, and that is distributed to the IT rack. There is one downside to this architecture, and that is the BBU, that is the battery backup, is in the same rack as the power and the power capacitor and the IT load, and everything is in the same rack. So to mitigate that, we recommend an architecture that is having the ATS power shelf inside the power supply. So there are structures that you can get the high voltage AC, 480 volts, as well as the high voltage DC, both of them in the structure, and have this power shelf with ATS allows you to have alternate sources between AC or HVDC in terms of if there is one failure. And that benefit is that the BBU is completely in a different zone, giving you that benefit to have that concerns about safety and fire outside. So we have a very close collaboration with NVIDIA. This architecture that you see is allowing a power distribution to get to 1 megawatt. We at Megmeet, we did 1 megawatt in only 19-inch rack, and that is compressed in one rack. This is a disaggregated solution with much less components. The copper is reduced by 45%, the TCO by 30%, and this is basically answering a lot of challenges with power, interconnects, sustainability, and many more. There are some boxes you see in the orange. The HPC is also Megmeet design, so I will go through that. So this is more details on the 1 megawatt. 7U on top is the PDU, AC or DC. Basically, I will show you the architecture in the next slide. 14U is the power, and that allows about 27U in the bottom for either battery backup or power capacitor shelf. In general, this is a 48U, and that gets you to complete 1 megawatt power. We have plans to release this part in mid-2026, and we have samples in Q1. This is a more detailed structure of the architecture. So as you can see, the 3-phase AC comes in inside the AC PDU, which is basically fuses. And that goes directly to the power shelf. And as you can see, power shelf converts the AC to 800. 800 on the bus bar is also directly connected to the DC PDU, which is contactors and fuse. And from this whole rack, the cables are, the HVDC cables are going to the IT load. This is basically the whole architecture. I am showing you the power shelf. 1U power shelf is 2 power supplies, and each power supply is 36 kilowatt. In 2U, you get 144 kilowatt, which is the AC to 800 volts DC distribution conversion. Communication is on CAN bus, and this is 98% efficiency. Megmeet is doing parallel design for BBU, which is the battery backup, as well as the cap shelf. It really depends on how much time you want for backup. So it can be 40 kilowatt for 60 seconds, 1 minute, or it can be 30 kilowatt for 90 seconds. And since these are all 1U, this is taking 1U in the shelf, so this is very dense design. Same as the cap shelf. Now I'm going to take you to the IT load rack. This is basically everything that is going into the server board. Probably for the next 2 years, you will see that 800 to 50 is needed because the server and PDB is still at 50 volts. So that conversion at about 90 kilowatt in 1U is giving you the DC to DC ready for distribution on the IT load. On the right side, you can see that the 800 to 50 volt intermediate, we call it high voltage bus converter. That is 3 by 3 inch approximately, and definitely has to be liquid cooled because everything else on that IT shelf is liquid cooled. So this is giving a real advantage in moving forward for any future distribution. With that, I am on the last slide. You can come visit us at the booth A59. Always follow us on LinkedIn. You get more information live on the social media. Thank you so much.